In this video we pay attention to a particular problem. We want to find a limit of a sequence. Find the limit of the sequence whose nth term is given by this formula. U index n equals n minus 1 divided by 2n plus 1. So the first way, there are two ways to do this. So the un is we give positive integer values. So we take positive integer values here, we plug them for n, and what we get back is real numbers. So let's take the limit of un as n grows to infinity, as n grows sufficiently large. N minus 1 is the numerator and the denominator is 2n plus 1. Now here we see that as n grows to infinity, both the numerator and the denominator go to infinity. So in order to alleviate this problem, we take a common factor n, and instead we have 1 minus 1 over n in the numerator, and in the denominator we pull out n, and inside the brackets we have 2 plus 1 over n. We can simplify the n's, so lim as n grows to infinity. In the numerator we have 1 minus 1 over n, and in the denominator we have 2 plus 1 over n. So as n grows to infinity, this term in the numerator, 1 over n, decays to 0. And this happens also, so this and this term, as n grows to infinity, of course 1 over n tends to 0. So we have that the limit of this is a half. This is the first way to do it. Second way, we define a function f of x equals x minus 1 over 2x plus 1. So this function takes values. The domain of this function is, so the 2x plus 1 should be not equal to 0. 2x should not be equal to minus 1, so x should differ from a half, minus a half. Is all the values of real numbers except the value of minus a half. Now we take this function then from the domain to R, and we take the limit of this function as x grows to infinity. So it's x minus 1 divided by 2x plus 1. Alright, now we have indeterminate form, because in the numerator and the denominator the quantities go to infinity, so we use the L'Hopital's rule. We take the derivative of in the numerator and the derivative in the denominator. So we have the limit as x grows to infinity, the derivative of x minus 1 is 1 over the derivative of the denominator, which is 2, and this gives me a half. So the limit of this sequence as n grows to infinity is equal to a half.